All right. So today should be pretty fun. First, I got a very cool email. My billing account was set up for IDT. That means your boy can order primers. Took them like 8 days to get off their butts and sell me the thing that I paid for. But it's happening. So that means we got to get this thing done because we got pretty much everything, and I want to have this done by September 30th because if I order my gene fragment, Twist is not going to charge me any shipping, and I get some Twist socks. I don't know why I'm doing a freaking shill ad, but I kind of want the socks. I also want the free shipping. Um, the thing is, we might have to redesign the construct because I realized when I was explaining it to someone that my whole premise uh, might be wrong, which is the whole idea of the time lapser is that we take a time lapse of a fluorescent protein that has been induced by something that is also metabolized by the host. Now, the way that I'm doing this is that I'm taking the LAX-Z gene out of PUC19. That might mean that it can no longer metabolize lactose. And if that's the case, then we will see a forever on signal, which is not what we want. We actually want a hump to see it go away. Because if we didn't want a hump, we would just use IPTG and we'd be fine. All right, let's get on to the CAD side of things. So this whole thing, I hated this. I really didn't want to do this, and I was thinking like, what could I do that would make this fun? And what would make this fun is using something that I've always wanted to use that is overkill and probably not even going to work that well. But we're going to do a couple of things. And the main thing is we're going to use aluminum extrusion. So bro, how do I just turn off tab groups ever? Like, tab groups are so stupid. Okay, I mean, whatever. So the idea here is we need to take some measurements. So I'm actually going to, um, we're going to try to get a rough model of this camera. And it's not going to be like an actual, you know, accurate. But we are going to do this. So we're going to just start. Actually, if we did a front plane, it might be even better. Can we get in there? Oh my god. That works. Okay. So that's the measurement we're going to take. Okay, I'm going to say 62 and a half. It's actually not right, but um but let's just see what we can do here. So, I guess what I'm going to try to do is like this type of thing where I go boom, boom, boom. The thing is, let's see. One thing that we need to do is work out. Okay, this thing actually doesn't extend all that much. So when it's at 10, the thing is it actually comes in a little bit at 12. And it bottoms out at like 15, it looks like. Or maybe like 14. And it comes out to 24. So we don't know really what that's going to be. So maybe what we'll do is we'll design two parts and one part that just has a good range on it. So, okay, so wait, let's get some measurements down. So the base general is gonna be 70. All right, so the lens inner camera hole lens diameter, camera and max diameter, camera lens lens diameter, like inner, like not with the attachment. I don't know, terrible name, but what was it? 70. So then what we want to do is the lens front thickness, and this is like, it's basically the thickness of the 80 millimeter part. Oh wait, but without the lens cap, right? Oh my god, this is scary. It's 13. Let's test it one more time. Actually, you know what? Just because I want to be extra, I'm gonna go get my micrometer. Bro, I got a micrometer. I just love the fact that I can say that I own a micrometer. You're looking at a guy that cares about precision. Okay, I also forgot there's one more little bit, which is that we actually have the Tiffin filter. So we should just put this on, I think. So how do we do this? Oh, it comes out like this. We should actually take some pictures with this thing. I don't think I ever took a picture with it. So I bought this for the excitation of GFP. Oh, we need a battery. Okay. But that's going to be the lens stack up, so that's what we have to measure by. But one thing that I guess I could do, nah, it's overkill. It's overkill. Let's just get to the finish line, man. All right, so that's the stack up. So that's what we're going to be working with. So actually, so all right, here we go. I don't have Mitutoyo money, so I went with the $40 mic, but it seems pretty good. To wait, to a micrometer, to a micrometer, 1,000th of a millimeter. That's pretty insane. Okay, so first let me just check. Okay, so we definitely can measure that. So let's. $17.2. 17.25. Okay, so what we're gonna say is that I just measure it one more time with these guys. Okay, 17.45. 17.5. Let's do 17.5. There's kind of a lip on it, but I'm not going to model the lip. So effectively, we are going to treat there's going to be a, okay, so, lens front thickness is 17.5. So, and that's going to be a diameter of, I think, 83, right? I'm going to change this to 82.75. That's the closer number that I'm getting. Okay. So what we're going to have is the let's say, the filters. I gotta go to the bathroom. Hold on. It's going to be the filters. And it's basically going to be just a cylinder. I wish I could just call cylinder. You know, it's kind of ridiculous that you can't just like Okay, so we're gonna rename this, so that's fine, but we're gonna rename this to lens front filter. Okay, I knew to do that. All right. Okay. This is not that complicated. So this is going to be the filter, and it's going to have a slider mate with the bulk of it. So I'm just going to call this the filter and then the lens. So that's what we're going to call it, the filter and the lens. Lens diameter inner. Lens thickness. For these radial parts, we're just going to call it thickness and diameter. Those are going to be the names for cylinders. I'm sure I've called them many other things in the past. Okay, so what we need to do is... Oh, that's sick. It stores it in an EEPROM or something. Or whatever. Persistent storage. Okay. So... Wait, we're measuring the depth. So what we want to do is measure... we want to go like... And there's a semi-flat face that I think we can... Okay, that's going to be the datum. Actually, wait, let's just keep the lens cap on and measure the thickness of the lens cap. Right? So... that's annoying. Okay. The mic is really not as useful as I wanted it to be. Okay, 6.5. Okay. Right, the lens thickness. So what we're going to do is we're going to measure... So wait, so this should then be... So 25 minus 6.5 is 18.5. But we said that the filter thickness was... Oh, wait, it's 24.5. Wait, so let's just say filter. Let's see the lens cap thickness. Filter. All that is so that we can easily then measure I'm just stopping it. Like 106. We have better datum here. 105. Okay, it's not like this the whole thing is not absolutely critical, but let's say lens or like lens filter thickness. Bro, I'm being so dumb right now. What did I say? 105? Okay, 105. We're just gonna do that. Okay. That's at the minimum. That's at like, so this is the minimum focal length, or what do we call it? I don't even know. Oh, zoom at like 14 or so. Min. Okay, so if we go to the maximum then, it should be like 14 more. Is that right? Bro, every single part on this thing is freaking curved. It is so insane. Let's just do it like this by eye. Or could we do it like... No, we don't have enough depth for that. $113. Bro, does that really not copy? That's so stupid. Oh my gosh. Just say 114. Okay, so that means that the lens travel okay. We also could have done it like this. Yeah, it's like 9. Okay, so now the lens itself. Well, I guess we could. Okay, well let's try it with this. So this is the lens. So we're going to, and we're just going to do a cylinder. And this is going to be lens diameter. And we're going to extrude this lens thickness. So we want the min. Okay, so what we want to do is we're going to fix. So wait, let's rename these things. So this is going to be filter. Okay, so now what we want to do is we want to fix the lens. And then we want to mate this to here. Except instead of a fasten mate, we want it to be what is cylindrical mate? Oh yeah, see that's good. What would slider do? What does slider do? Wait, what's the difference between a slider and a cylindrical mate? Oh really? I didn't see it rotate. Okay, that's fine. Let's make it a slider mate. And then we want the limits. So the Z. So I think we want this and then 9, right? So if I play this now, and then we just want to flip this. Oh wait, that's not what we want. Um, oh, I think wait, I think that this should be fine. We just need to take this. Or wait, travel. It's not moving. I feel like this didn't even move. What? I don't understand. Okay, maybe it did move. Okay, there we go. So that's going to be the lens. Realistically, I should do the tracing thing where I just trace it out. Just the the inaccuracy of the parallax and everything gets me really pissed off. So okay, but we did it. So now we need to um well, okay, let's just like mess around a little bit. So if we were to insert top plate. Wait, why is that? What? What? How is that possible? I feel like it's rendering weird. What is that? How did that even happen? Okay, that was funny. Okay, wait, this actually matters. So, I can't tell. I think I think that should go here. We should add a label because um here to here 55, here to here Okay, so it's actually like this. That's actually fine. I'm okay with that. Well, actually, I'm not okay with that. Let's undo that. So I want this one to go there. I think it's better if it's all facing the same way. What the hell is going on here? Oh, shit. Okay. I don't know if I'm gonna have room for this. This thing, man. Because, okay, this is sitting like this. So what we need to figure out is... Actually, we might have room. We want to figure out the distance between... this screw, the 1/4-20 screw plane, and the mid plane of the lens. How are we going to do that? I think I'm just going to take a depth measurement and just kind of eyeball it. I don't like this type of CAD. I like the type of CAD where it's like, you know it's right. But sometimes you don't always have that luxury. Can we do it like this then? Nothing has an edge, man. All right, hold on. So what we're going to try to do... All right, let's just do it like this then. Is... I want to go like this. Okay, so the camera is going to be hanging like this, attached to some aluminum extrusion. And we kind of want... just this part to just barely be in there. Okay, but what... Okay, so here's what we care about. Yes. So what we're caring about is... dude, nothing... I hate the casting on this thing. If I were to design a camera... I mean, like, yeah, it's nice to hold. And I actually, you know... But as a person that has to model around this is crazy. Everything has a little bump. Actually, designing this sounds miserable, dude. It's so challenging. Okay, what can we measure? Because this is our data. This is the only flat surface on the whole damn thing. So actually, what if I just lay it flat? Okay, 45. Um, I think it's 45. So if we said like lens mid-plane height or something. But actually what we could do is if we shimmed this with maybe this paper or something. That's pretty good. And then we just that's the thing about these cylindrical things. I guess what we could do is we could still divide this by 2. So if we do this. Okay, so that says it's 80. I'm actually more inclined to trust that measurement than if I hold this. Wait, no, but see, this is offset from the ground. So what we want to do is we actually want to measure it to the paper, but the thickness of this paper isn't enough, right? It's pretty close, though. I mean, this says it's 40. I think it might be 40. Because okay, I'm gonna say it's 40. So what that means is okay. Wait, let's just do some messing around. So this is going to be the just call it camera mount. Wait, this is not what I want. I wanted to Okay, so basically what we're gonna do is so we're gonna sketch on here and here. Oh, that's why they do these slotted so that you can actually pick the inside and the outside. That's why they do them slotted. It's just like the tape measure. That's crazy. All right, but let's just for right now, because I think that all we need is to do this. So we need a point. Oh wait, we need a point that's like this, and a point that's like this, and then we need a simple, not tapped, drilled drill set. It's actually gonna be a clearance hole for an M6. I always think P is for point, but it's not. Or actually, wait, can I do this? Oh, it's also for collisions, because I think that if you were to, no, what? 1220. Actually, come up with the mate connectors. Let's see, see if anyone has a YouTube video on how to build stuff with aluminum extrude, because I bet there's some good tips that I could pick up. Uh, oh yeah, actually, this is kind of what I want to watch. Some T-slot. This is like the perfect video.
You can quickly assemble a pair of components with only one mate. Mate connector points automatically show up with the most probable locations, such as the centroid of the face, midpoint of an edge, and the endpoints. You can have additional layers of positional control by offsetting the mate connector, which is nothing but a local coordinate system. Now, what if you are working with T-slot aluminum frames? This is commonly used in modular designs for any automated machinery, a rather versatile structure because it allows you to mount different equipment at different positions with great flexibility. You can always make the component directly by offsetting the positions. You can also create a mate connector at this intersection point using the between entities option. However, note that the Z-axis is not outright. This is good for creating spider mate, while inserting components upright still requires additional setup. This simplifies the offset measurement, since the distance to the flank is usually not a round number and also not part of the design intent. If you are looking for a one-time fit-for-all setup that aims for quick mounting, you can define a custom placement location with explicit mate connectors using either sketches or offset. Let's start with sketching a quarter box on the end face. Then you can create two types of mate connectors easily, one upright and one along the sliding direction. Next, you can replicate these to other slots using pattern or mirror features. Check the reapply features.
Oh, broski. Wow. You're blowing my mind. So you add two mate connectors, and then you do a circular pattern.
Check the reapply features if you want the secondary axis to be the same. If the design intent requires that home position be at the center, simply modify the sketch plane to the midplane of the frame. Now you have...
Okay, so let's try that. So in 2020, what we want to do is we want to add... How did he do it exactly? So he drew a sketch, and then he just added mate connectors by changing the axes. Okay, I'm gonna get some more coffee. I like that they put radii on these. I should, or at least a chamfer. Mine looks so blocky. Anyways, so we're gonna sketch on here. Oh wait, we want a G. Okay. And then, but we want this to all be construction, right? And then we want to do mate connector on here. I think if I clicked, let's see, I think that's what I want actually. So I want that one. And then I want that one again. Control M. But we want to realign. Oh no, we want to realign it to this way. No, wait. We want to realign it to this way? No, we want it so that the Z is... Wait, hold on. The primary axis... What does this mean? How did he do it?
Sketches or offset. Let's start with sketching the quarter box on the end face. Then you can create two types of sketching the quarter box on the end face. Then you can create two types of make.
Okay, he like selected a line that was pointing that way. So if instead I did, so wait, let's delete both of them just so we understand what the hell is going on. So if I selected like this line and then I did Control M and then I clicked on this, mine didn't point forward. So there's that, realign, primary axis entity. I feel like we want it to be that way. And then secondary axis, we want it to be this way. And then we want to flip it. So now, I don't even know why we're doing that one. That one doesn't even seem that useful though. But no matter. I'll just do it. I'll just do it. I don't even know. Okay. And then circular pattern. Part pattern, feature pattern, these patterns, axis of pattern. Okay, cool. So that should be somewhat useful. Let's see. I don't even know. It's kind of fun. So wait, do we have the mate connectors or did they not like update? We should have the mate connectors. So then if I go here, I don't know, they're not showing up. Maybe I have to like regenerate them. Let's try to delete it and do it again. Oh. Maybe it was on the other side of it. Did he show how to put it in an assembly? Because that didn't help me at all. But if I did this, and then I just offset it by, let's see, Z is this way. This would be the edge to edge over 2. And then flip it. Not flip that. Oh, what? Oh, yeah, because that's not right. That's not what I want. But we actually have this measurement. It's the 6.1. Wait, there's no 6.1. Oh, yeah. I gotta go to Amazon. Okay, so we need to just make a new variable. It's gonna be the square edge. It's gonna be the 4.3 plus the 1.8. So square edge to T outer edge. I don't know what that means, but like distance, I don't know. So this is going to be the 4.3 is a square edge to inner plus the 1.8 T thick. Okay. But that's not the way that I want to do it. So let me see if did the video explain how he did the
connectors easily, one upright and one along the sliding direction. Next, you can replicate these to other slots using pattern or mirror features. Check the reapply features if you want the secondary axis to be the same. If the design intent requires that home position be at the center, simply modify the sketch plane to the midplane of the frame. Now you have an aluminum frame that is good for quick mount. The rest is just to rename the frequently assessed.
Is he in a part studio? No, he's in an assembly, but how did he do it?
Features or use the name positions to keep track of changes.
Oh, that's dope.
Or use the name.
But I wish he would show. Like, did his. Let's see. Wait, then what is the point, though? Wait, in the assembly tab, use the make connector tool directly on part geometry. If you really want your custom connectors defined once and reused everywhere, in the part studio, create your make connectors. You do right click the make connector, select make connector, insert into assemblies. Okay, so that's all I have to do.
showing the points with the mid connection. You want to take it by the mid connection. Also perform social change the they are not aware of that. You can also, I already mentioned about that. Yeah.
Oh, there we go. Oh, okay. So yeah, so my mate connectors are owned by. Oh wait, owner entity. Oh. Oh, interesting. We can just select the part. Yeah, boy. So that'll probably work, won't it? Wait, why do we only see one of them? Oh, because we didn't do both of them. Beautiful. Okay, so that's cool. So now what we can do is we can just go like this. And then get that. And then just offset the X by 10. Oh, I guess I messed that up. By 10. Oh, this is supposed to be 0. This is supposed to be minus 10. And then you just put a T-nut in there. I'm realizing now that my design will be bad, but right now we're sort of doing exploratory CAD. We're not really uh um oh, interesting. Oh, I see. Okay, wait. So if I did what? Bro, I really messed up those mate connectors. Okay, so this is kind of what I was thinking. And then we insert this part again. Let's rename this thing. So I don't know how far apart these could be, because um okay, well let's just guess it's gonna be like 60. The interesting thing here is that, okay, so a piece of aluminum extrusion is gonna be butted up against this thing. That's 60. All right, I don't think there's any clearance issues there. Let's do this. So we want to mate uh yeah, this to here, offset. Let's see, Y is that way, so let's go like 60. I don't know. And we got to reorient this. Oh. Yeah, I should fix those mate connectors. Those mate connectors stink. Can we do a mirror on this thing? Assembly mirror? That's great. Let's try that. So wait, we need a mirror plane. So first off, can we get a plane? So we can't get a plane, but we can do assembly mirror, mirror plane. How do I select a mirror plane? I want to be able to make a plane though. So there's this. Can I just offset it? I don't want that. Wait, but I can get that guy. That's the plane. I want that plane. And then we want to mirror this thing, and this thing. We could just as easily have these pointing inward, but the biggest concern for me about this whole thing is, one, it's going to be super tall, so I'm going to have to build some way to onto mount the device onto the table so everything is really if I drop this camera, bro, my whole career is fucked. So but the idea here is we're going to have this camera that sits flush facing down. So wait, let's add another L. So we want this let's just try it. I don't know. We want to offset, it looks like X by -10. I can't move that up. I guess there's no so this thing could be all strong. And just out of curiosity, what is the size of this thing? What is the size of this thing? It's like 135. Ugh. Okay, wait. Let's just try to. I think we'll probably have to create a version. But in here, insert other documents, T-slot and illumination, create a version, mate connectors, and L bracket. This is gonna be huge. I guarantee it. Oh, actually, we have a lot of room. So if I were to just try to mate this to here, flip it around. Then once we have that, wait, can we do the actual appearance too? Okay, I'm gonna end it. All right, we got some progress in, but this is mostly nothing.